Hi everyone, in this video, we will introduce RegMiner, a tool which allows us to mine replicable regression bug dataset from code repository. When we are developing and maintaining a software project, a function can work well 3 months ago, but unexpectedly fail now. In this case, we say that a regression bug happens. Regression bugs are usually caused by unintended modifications to an existing function. In the software engineering community, researchers have developed many techniques to address this problem. Regression testing techniques are designed to discover whether some code changes can fail a working function or which test cases can be used to discover a regression in a more efficient way. Regression localization techniques are designed to explain and debug why the new version can cause the failure, or identify the failure-inducing changes between the working version before and the failing version now. Regression repair techniques are designed to derive a fixed version from the failing version and the previous passing version. However, the community still lacks a scalable benchmark to evaluate those techniques in a systematic way. Our investigation on 15 research works from the year of 1999 to 2021 shows that the number of evaluated real-world regressions is small. Moreover, different benchmarks are used in different work, making it difficult to compare their performance. A large-scale benchmark can not only mitigate the issue, but support various systematic empirical studies on regressions. In this work, we introduce RegMiner to automate the collection of runnable regression bugs from the code repository with zero human intervention. Each mined regression bug is reported by a regression fixing commit, a regression introducing commit, a working commit, and a test case can pass the regression fixing commit, fail the regression introducing commit, and pass the working commit again. This work is published in ISTA 22 research track. RegMiner takes input as a set of code repositories and generate regressions as output. The whole framework consists of 3 high-level modules. A repository parsing module to select the bug-fixing commits with good regression potential from the input code repositories. As a result, we can collect a number of bug-fixing commit, each of which is attached with a test case passing the commit but failing the commit before. A commit validation module to verify whether a bug-fixing commit is also a regression-fixing commit. RegMiner achieves this by compiling the code versions and searching for a previous commit where the test case of the bug-fixing commit can pass. When the regression bug dataset is constructed, we also provide auxiliary functions to recommend which change in a commit is critical for regression fixing and regression introducing, support user to annotate the critical changes, and search some specific bugs. Next, we show a demonstration of our tool. 1. The user first needs to specify the Git projects fed into our RegMiner as input. In this version, we support the specification in terms of Git user ID and Git repository ID. Then, the tool will pull the repository from the GitHub website. 2. Next, user can open the mining dashboard. There is a start and stop button in the right, which allow user to resume and stop the mining progress. When the user clicks the start button, RegMiner can show 2 progresses. First, we show the progress of processing project by the ratio of the number of the processed projects over that of the total projects. It allows us to observe how the projects are processed to find bug-fixing commits. Second, we show the progress of processing bug-fixing commits by the ratio of the number of the processed bug-fixing commits over that of the total found bug-fixing commits. It allows us to observe how the bug-fixing commits are confirmed as regression-fixing commits. 3. User can further click the Show Found Regression to further investigate the found regressions. Then, a list of found regressions will be shown. A click of any of the regressions, RegMiner can further show its mining process. The timeline represents the search order of RegMiner from the bug-fixing commit. Each point represents a visited commit. The green points represent the commits where the test case can pass, the red points represent the commits where the test case can fail, and the gray points represent the commits which cannot be compiled. The search process starts with the regression fixing commit and ends with the working commit. Click on any node in the search process, you can see the commit information and migrated code of the node. For, after the mining process is over, we can click the Regression tab and see the overall regression dataset. Each regression is listed with its ID, project name, regression introducing commit, regression fixing commit, working commit, and the test case name. Clicking any of the regression bugs allows us to see its details. We can investigate the relevant changes and run the test case against regression introducing commit, regression fixing commit, and working commit. The test results will be shown in the console. 5. In addition, RegMiner is further integrated with critical change recommendation function. Note that the number of changes between the versions before and after the regression introducing commit can be huge. The user can investigate which changes are the regression introducing changes or fixing changes with our recommendation. 6. Moreover, RegMiner further allows user to either confirm the recommended critical changes or annotate the misreported critical changes. 7. Last, we further support the users to search for the regression bugs with keywords. Technically, RegMiner matches the keywords with the runtime message and code diff between the commits.